Hi, welcome back. In this video of solving quadratic equations, we will talk about the quadratic formula. Now, you might recognize this formula from a different algebra class from before, right? But this quadratic formula allows you to solve any quadratic that is written in standard form. So if you have a quadratic that is in this notation, where A, B, and C are all on the same side, you're going to be able to plug in the values for A, B, and C, right? You're going to take those coefficients, plug them in here, and by doing some PEMDAS, right, simplifying, you're going to be able to find the solutions for any quadratic equation. So I'm going to do a few examples here with you. I'll end up doing probably 2 or 3 examples, and I'll show you how to manipulate any quadratic and how to use it with this formula. Let's get to it. So here we have a quadratic, right? We have 2x squared plus 11x plus 5. And I wrote the equation on the side so that you can have it as reference. You'll never have to memorize this, right? Our goal is to just apply formulas versus memorize formulas. Now here I can tell that my generic equation is already in the correct order. If I did not have bx in the middle, or the highest polynomial, the highest exponent here as x squared, and the 5 is my constant, I want to rearrange them first. Right? I don't want to misidentify the a, b, and c coefficients if these are not in the correct order. So I know here that a is equal to positive 2, b is equal to positive 11, and c equals positive 5. So if I know these values, I can plug them in here. Now I'm going to take all of these values and I'm going to put a parentheses for them. So x equals negative of whatever b is, plus or minus the square root. Whatever b would be squared minus 4 times whatever a is times whatever c is. All of these divided by 2 times whatever a is. I like to use parentheses because I can plug the numbers as they are. If they're positive or if they're negative, I can plug them in here and I can let the negatives take care of themselves. And I'll show you an example here in a minute that involves negatives. That way you see how the negatives are affected. So negative b, I'm going to plug in 11. B squared, 11 squared. 4 times a, which is 2, times c, which is a 5. And everything divided by 2 times a, which is 2 times 2. Okay, I'm just using these 3 values, and I'm plugging in anywhere that I see those letters. Now I do PEMDAS. I'm going to simplify. I'm going to do order of operations. Everything that I know, right, will continue to be the same. This turns into x equals negative 11 plus or minus the square root of 11 times 11 is 121. 4 times 2 is 8. 8 times 5 is 40. And then on the bottom I have 2 times 2, which is 4. Now I can simplify a little bit further inside the square root. X equals negative 11 plus or minus the square root of 81. 120 minus 40 is 81, and divide everything by 4. Since 81 has a square root, I'm going to simplify it even more. The square root of 81 is just 9. And you know how in our previous video with the square root method, we spoke about how when we square root both sides, we have to account for the fact that a quadratic has 2 sides, right? It's symmetrical, so it's going to have a plus side and a negative side, right? 2 sides to the parabola. This accounts for that already. The quadratic formula accounts for the fact that the x squared will result in 2 sides of the function. So what do I have here? I have x equals negative 11 plus 9 divided by 4, and x equals negative 11 minus 9 divided by 4. And here I continue to simplify them, but I now know that I'm going to be doing addition and subtraction. Negative 11 plus 9, it gives me negative 2 divided by 4, which simplifies to negative 1/2. And at the same time over here on the right side, I have x equals negative 20 divided by 4, which gives me negative 5. Here I got my two solutions. I am able to use the quadratic formula for any kind of quadratic, as long as it's in standard form. Now, as a side note, I can do this problem also by using my other method, right? The factoring method, where I find the factors of the first column and the factors of the last column. And then you cross multiply, check the additive, right? You can check those other videos. I made another video for solving quadratics using factoring method. Feel free to check that out. But my goal here is to expose you through different approaches on solving quadratic equations so that ultimately you can decide what method works best for you. And what method are you able to do based on the current scenario. Let's try another one. Now notice the difference between that problem and this previous problem. In this problem, I don't have all of the values on the same side. I don't have A, B, and C on the same side. So I need to move these values to the left. It doesn't really matter if you move the 2x squared to the right or these two to the left, as long as they're on the same side. Yeah? So the problem can look like this. You can move them to the right, or you can move them to the left. As long as they're all together in the correct order, it's not going to matter. I'm going to move everything to the left. I'm going to subtract 5 so that I can move it to the left. I'm going to subtract 3x. On the right side, I'm going to have 0. And on the left, I need to organize these so that the x squared goes first. The bx goes second, which is negative 3x. And then the constant, the minus 5, goes last. That way, I can properly identify A, B, and C. As you can see here, A equals 2, B equals negative 3, and C equals negative 5. Now we have a few negatives that we're going to be plugging into our general equation. Feel free to pause the video and then give it a go. Try it yourself. See if you can plug the numbers in, simplify it, and then press play again and you can see if we got to the same solution. So I'm going to plug into the equation x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. I'm putting this little thing at the end so we can know that all of this is included in the square root. All right, let's plug numbers in. For b, I have a negative 3, so I'm going to plug negative 3 for b. See how it says minus b? It's minus whatever b is. In this case, it's minus a negative. I'm going to plug negative 3 inside here for squaring. 4 times a, which is 2, times c, which is a negative 5, over 2 times a, which is positive 2. The negatives here are going to be crucial because, as you see our next step, negative of negative 3 makes it a positive 3. And then when I square negative 3 times negative 3 turns into positive 9, minus 4 times 2 is 8. 8 times negative 5 is negative 40. I'm subtracting a negative, which will then affect that here in a little bit, divided by 2 times 2, which is 4. Okay, now this minus a negative will turn into a plus. So x equals 3 plus or minus the square root of 9 plus 40. And divide that by 4. And we continue. Here we have the square root of 49 divided by 4. Had we not done a negative here at the back, we would have gotten 9 minus 40, which would have changed this to a whole other problem, right? Like negative 31 or something else. So make sure you watch out for the negatives, okay? Let's simplify the 49. X equals 3 plus or minus the square root of 49 is 7 divided by 4. And now I can split this into my two parts. I'm going to do this here on the right side. I have x equals 3 plus 7. And I also have x equals 3 minus 7. Right? There's two parts to this problem, the plus or minus. As I continue to simplify, I get 3 plus 7 is 10 divided by 4. And then over here I get 3 minus 7 is negative 4 divided by 4. Now I can always simplify further, right? If I can simplify a fraction, keep simplifying. 10 divided by 4, you can divide both by 2, which turns it into 5 halves. And then 4 divided by 4 is 1. So this gives me a negative 1. Here are my two solutions. Again, this method only works if everything's on the same side of the equation. As you move them over to the other side, the signs change, and then put the signs in the parentheses so that you can see how the minus and negative turns into a positive, right? And then subtracting negative 40 is affecting it. If you're able to take your time with the parentheses and the negatives and each step along the way, trust yourself through the process, and you'll eventually get to the solution. All right, let's try one last one. Okay, so here, I first need to take care of the 5. I'm going to move the 5 to the left. Yeah, I need to move this over here. I got 2x squared plus 12x, and then instead of minus 5, I'm going to add 5 to the other side. So plus 5 equals 0. Yeah. I have A, B, and C in the correct order, so I can see that A equals positive 2. B is equal to positive 12, and C equals to positive 5. See here all the coefficients are positive. I'm going to plug into my formula, and I continue to simplify as we just did earlier. So, x equals negative b, which is 12, plus or minus the square root of b squared, which is 12 squared, minus 4 times a, which is a 2, times c, which is a 5. Divide everything by 2 times a, which is a 2. Once I plug in the numbers, I can do some simplification, right? So let's see. X equals negative 12, plus or minus the square root of 12 times 12 is 144, minus 4 times 2 is 8, times 5 is 40, divided by 4. 144 minus 40 gives me the square root of 104 divided by 4. Now, does 104 have a square root? I'm going to do some side work here in a little bit on the right. Let's see. 104 does not have a square root. 10 times 10 is 100, and 11 times 11 is 121. But I can break 104 into something that does have a square root. Like, I can replace 104 with the square root of 2 times the square root of 52, since it's an even number. I can also break this into the square root of 4 times the square root of 26. And I can also break this into the square root of 8 times the square root of 13. Which of these will I want to choose? I'm going to go with the one that actually does have a square root. My whole goal here is to simplify the radical. And I cannot square root any of these numbers or any of these. But 4, I can square root. So when I rewrite it as square root of 4 to square root of 26, 4 comes out to positive 2. And 26, I mean, you can break 26 into 2 times 13, but neither 2 or 13 have a square root. So I just leave it inside. Now I can replace 104 with a simpler form, which is 2 radical 26. Negative 12 plus or minus 2 radical 26, all divided by 4. In our previous examples, we ended up having scenarios where we had the square root of 29, or sorry, 49, which was a nice whole number of 7. Or we took the square root of 81, which came out to a whole number, number 9. Here we have a square root of something that does not have a nice whole number. So we need to simplify it and then replace it with the simplest form. Now here, I'm going to split the problem into 2 parts, right? Because I have a radical, I'm not going to be able to simplify it to a nice whole number, but I can split this into negative 12 plus 2 radical 26 over 4. And the other side, x equals negative 12 minus 2 radical 26 over 4. If these numbers didn't have anything in common, what I would do is I would stop right here. Those would be my solutions. I have 2 solutions to the quadratic. But I do notice that these values all have something in common. They're all divisible by 2. Now, I can't really divide 26 by 4 because 26 is in the radical and 4 is not, and these are not like terms. So I'm going to temporarily change that to like a happy face, right? Let's say that we have x equals negative 12 plus 2. Instead of the radical, I'm going to put a little happy face divided by 4. I just want to pronounce, right, or accentuate the fact that the 26 cannot be touched with. I cannot simplify. I can simplify all the other numbers, 12, 2, and 4, negative 12, negative 2, and 4. All of these values are divisible by 2. But I don't want to accidentally divide the 26 as well by 2. If I can simplify all 3 terms by something, I will reduce it to something smaller. So let's do that. Divide that by 2, divide that by 2, divide that by 2. And that gives me negative 6 plus technically a 1, right? 1 happy face divided by 4. Knowing that the happy face represents the square root of 26, right? That's really where this came from. I just replaced it with something else so that I don't simplify it on accident. Over here, I get negative 6 minus 1 happy face over 4. Yeah? And now that it's simplified, I can replace the happy face with the original problem, right? The radical. Because that's the actual solution. Negative 6 plus radical 26. I don't have to put the 1 in front of it, right? 1 times something is itself. So saying 1 times radical 26 is the same thing as just saying radical 26. And here I have negative 6 minus 1 times radical 26, which is just 26. You totally don't have to change the radical here to a happy face. I just prefer, because I know my tendencies, is that if I put a radical 26, when I start to divide numbers by 2 to simplify, I might accidentally divide the 26 also by 2, and now I'm breaking some rules, right? So here are our 2 solutions. We got negative 6 plus radical 26 over 4, and negative 6 minus radical 26 over 4. If you think back to the original problem, I want to show you something real quick. 2x squared plus 12x plus 5. Could I use another method? Well, I cannot use the square root method because I have multiple variables that I'm solving for, right? We can't do PEMDAS backwards. Can I do factoring? 2x times x is 2x squared, and then 1 times 5 is 5. But when I cross multiply, do these values add up to 12? No. This kind of quadratic is non-factorable. And I could tell that it was non-factorable Because the solution had a square root of a number that could not be simplified, right? This is basically a decimal. So, whenever you cannot factor a quadratic, you cannot find the combination that gives you the original quadratic, we're going to have to use this method. Yeah, we're going to have to use that method in order to solve for x. But if the original problem is factorable, you can decide, do I want to go through this process with the quadratic formula, or do I just want to take a different approach? And that's really why we have these last 3 videos. Solving quadratics by factoring, solving quadratics by square root method, solving quadratics with the quadratic equation, or the quadratic formula. So, that ultimately you get to decide which method do I want to use. This method will work for any problem that's in this form, factorable or non-factorable. I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe. And as always, we'll calculate it. Actually, before we call it a day, what does a mathematician's baby drink? Ready for it? Quadratic formula. You guys have a great day. We'll calculate it.